I keep getting the thing. Right there, Spain.
Okay.
Don't even let you talking.
Here we go. We started. So here's where it starts. We're going to do problems from all 4 of these puzzle pieces.
Yeah.
All 4 of those practices, because it will sum up the entirety of 8A. Now let me just do that for you in a little map over here. We have the mole. Okay? And the mole is very valuable because we can use it for a lot of calculations. The mole is equal, 1 mole is equal to the molar mass. You should probably write what I write. In grams of any compound or element. One mole is also equal to 6.02 times 10 to the 23rd particles, which is a catch-all term for atoms, molecules, and formula units, which I call FUs. One mole is also equal to 22.4 liters if we have a gas or liquid. So no matter what form the substance is in, even if we have it down to the particles, we can calculate the amount that we need, and that is very, very important for industry and for making things. And so we do these calculations and we can go back and forth between mass and the mole. We can go back and forth between particles in the mole and back and forth between liters in the mole. This is called the mole map, and it's in your notes. So what we're doing today is first, I'm going to show you what molar mass is and how to calculate it. That's the first puzzle piece. Then I'm going to show you how to use the molar mass to go back and forth between moles and grams. After that, I'm going to show you how to use the mole with particles. And then we will end after I show you how to use the mole with volume. All of that is 8A. And it is all combined in the puzzle piece. And you will go one-step calculations, back and forth. 8B is when we do this in multi-step calculations and go back and forth. Different arms of the moment. So you're going to want to know this. But now we will start with molar mass, and I'll show you a couple examples, then we will move to more, and I'm going to show you 2 to 3 examples in every single one. So we'll wind up doing 10 to 12 practice problems, and you will want to show the difference between what section we're working on in your notes. You may want to write down the problem as well when we get there, but definitely write what I write. ¿Entiendes?
Sí.
¿Estás listo?
No.
I think you're making people cringe.
Yo sé. It's part of my job. So up first, we're going to calculate molar mass. We're going to do this step right here that you have to do in order to just do this branch of the mole map. So, what is the molar mass of Br2? Br2 is a diatomic molecule of bromine bonded to itself. And we need to get the mass of it. In order to get the mass, we go to the mass of bromine, 79.904 in the periodic table, and we add it up. 79.904 plus 79.904. This will equal the molar mass of bromine. Well, Br2, that is. When I add it up, I get 159.808 grams per mole. So if I have 1 mole of Br2, that mass is equal to 159.808 grams. It is the molar mass. And all we did was add it up.
Wait. Or did you round? Did they round them?
Yep.
Do we have to round all of them?
You'll be able to tell. It's in the answer choices.
There's nothing good.
Sometimes. If it comes down to rounding, then you did it wrong. Are you recording? Thank God, because I forgot to tell you to start.
I'm pretty sure. It is recording.
Audio, video, whatever. I would prefer she had the video because
Yeah. Don't worry, I got you.
I would have preferred that.
I know. Okay. So that's the first one. Let me show you another one that's a little harder. Y'all be killing me with this. This is BeCl2. That is not an I. And I guess context matters because you have to know that you're not going to see a triple combo of carbon with beryllium and iodine. It's not going to be that. If you see a C, then something that looks like an I is a L. That is Cl2. That is beryllium chloride. 1 beryllium, 2 chlorines. It's the same font as your phone, so I don't know why we be messing it up. Maybe Savannah will laugh. She just did. You know it. So we are going to get the mass of BeCl2. All I have to do is add 1 times beryllium plus 2 times chlorine. That's 1 times, what's beryllium? 9.012 plus 2 times 35.453. Okay, I add them up, and what do I get? Did anybody actually do that? Because that's a guesstimation. Do you need me to show you that in Desmos? No, I'm not doing it. 79.92. So we added up and we got our molar mass. Make sense?
79.9.
Thank you. All right, one more. Let's do this one. Ammonium sulfate. Gross. Yes, we have to add all of this up. I'll give you the masses while I talk if you type them in and actually do the calculation. Deal? You ready? Somebody, get your Desmos out. Okay, here we go. So we have 2 around this parenthesis, so we have 2 times N and 2 times H4. So 2 times N is just 2 times nitrogen's mass, which is 14.007, my favorite mass. I'm a James Bond fan. Then we have 2 times 4 equals 8 times the mass of hydrogen, 8 times 1.008. Then we have just a single sulfur, which is 32.066. And then we have oxygen. There are 4 of them. 4 times 15.999. When you add all of that up, it gives you the molar mass of ammonium sulfate. Good. It's 132.14. So, the mass in grams of 1 mole of ammonium sulfate is 132.14 grams. Easy. All you're doing is adding it up based on the periodic table. That is the first skill we're covering. We finished the first skill. The second is how do we use molar mass to convert to moles? And we're going to learn the process that you repeat all the time. Here we go. I can close this tab. Now we are going to convert moles to mass. Can I erase this? You ready? So this is now the second section in your notes where we take the molar mass and we actually do something with it. The question reads, how many moles of CH4 are contained in 96 grams of CH4? This is the practice puzzle piece, convert moles to mass. Number 1. How many moles of CH4 are contained in 96 grams of CH4? So we need to basically convert from grams of CH4 to moles of CH4. In order to do a conversion, we have to use dimensional analysis. So we are going to do 96 grams CH4, and we use the molar mass to convert to moles. Here's how we do it. We take our given and we always put it in the top left. Then we take the unit, gram CH4. We have a backup recording going, right? Just in case. Keep going. Keep it on. So gram CH4 is going to cancel with gram CH4. And we're going to have the 90, Sorry, I distracted myself. So we need to end in moles CH4. So gram CH4 is going to cancel it out, and we're going to have the molar mass here in order to help us do that. Well, the molar mass of CH4 has to be calculated. But guess what? Our answer choices are nice and clean, so I can round my masses here. So I'm just going to do carbon is 12, that's C, plus there are 4 H's, so that's 4 times 1, because the mass of hydrogen rounded is 1. So when I do that, I have 12 plus 4 equals 16 grams. That is the molar mass of CH4. That is the special number that will allow me to convert between grams and moles. So now I just do the math in my dimensional analysis. I have gram CH4 cancels out, and I end in mole CH4. Now I do 96, multiply across the tops, divide across the bottoms. 96 times 1 divided by 16 equals 6. Thank you. 6 moles of CH4. What? It seems complex, but pretty soon you'll go through it really fast. You will. Can I go on? Okay. Now, on the convert moles to mass puzzle piece, I'm going to number 3. Can I erase this? What is the total number of moles contained in 115 grams of C2H5OH? So, same steps. I'm given 115 grams C2H5OH. And so it goes in the top left. What do I do now?
C2H5OH.
Yeah, what do I do with it? Yes, I drag down gram C2H5OH on the bottom and 1 mole on top because that's where I'm going. I'm going to 1 mole, and 1 mole equals the molar mass in grams. So now I have to
get the molar mass.
I got to get the molar mass. Good. And look, pretty answers again. So I'm going to use the rounded versions. Mass of C, 2 times 12. How many H's?
5.
Plus 1. 5 H's here, another H here, that's 6. The mass is 1. And then oxygen, 16. 15.999 rounds up to 16. I got all of that from the periodic table. So now I have 2 times 12 is 24, plus 6, plus 16. 24 plus 6 is 30, plus 16, 46. That looks like my mother's handwriting. That's crazy. Grams will cancel. And now I just do 115 times 1 over 46. And I get what?
2.5.
Very good. 2.5 moles. And that's it. That's how you go from mass to moles and moles to mass. So we have done figuring out the molar mass, and now we've used it in calculations. Next, we're going to go to moles and particles. We're going to go to the third puzzle piece. It says practice, convert moles to particles. Can I erase? We just did mass to moles. And we used the molar mass to get there. Now we're doing moles to particles, and this time we're going to use Avogadro's number to get there. Well, what you're going to like is from here on, you don't have to calculate anything as a middle step. You just do dimensional analysis based on this number. Molar mass changes, and you have to calculate it every time. But Avogadro's number and 22.4 do not change. They are constants. So that will be very nice moving forward. New section. I'm on convert moles to particles. And this is nice. You won't even need a calculator. I'm on number 1. We're just going to do the setup. Once you have the setup, the numbers will flow. So, 4 moles of water is made up of 2.408 times 10 to the 24 molecules of water. This is the answers. We just need to put them where they go. Label the chart below to show how you would set up converting moles of water into number of water molecules. So we need to go from moles at the beginning and end in molecules. And we're going to set it up. I start with my given. 4 moles of water. I have 4 moles of water. Then I need that unit to cancel. What goes on the bottom? 1 mole. Good. And when we have molecules, we always have 1 mole equals 6.02 times 10 to the 23rd molecules. So Avogadro's number will go on top. And now everything's going to cancel. And if we ran this in the calculator, 4 times 6.02 times 10 to the 23rd, you would get 2.408 times 10 to the 24. Solid. Got that written? Number 2, same thing, different direction. 4.22 times 10 to the 24 individual iron atoms is equivalent to 7.01 moles of iron. Label the chart below to show how you would set up converting number of iron atoms into moles. So this one is going from atoms to moles. So where do we start? Yes, how many? Good. 4 point atoms on top. So what goes diagonal? 6.02 atoms on bottom times 10 to the 23rd. And where are we trying to go? Into moles, so on top, 1 mole. And when you do that math, 4.22 1024 divided by 6.02 1023, you get 7.01 moles. And that's a setup just going in the opposite direction. That's all it is. Setting it up, put it in the calculator. It's much easier when you don't have to calculate the molar mass as an intermediate step. You're just using Avogadro's number. That's all it is. Hopefully this test will be easy for you. Somebody let Fernando in. So here's a real one. 5.1 moles is equal to how many particles? Easy. 5.1 mole. What do? 1 mole at the bottom. On top. Avogadro's number, that's fine. And when I do 5.1 times 6.02 times 10 to the 23rd, I get 30 something. It's actually 3.0 All I did was multiply. Very easy. We're just canceling units, and it tells us what to do from there. Okay, hang in there. Now we're going to do liters, and then we're done. But it's the same skills, different numbers. Can I erase? All right. I'm on the fourth practice puzzle piece. Convert moles to volume. I'm doing the first three problems and then we're done. These first three are the same skills. This time our special number is 22.4 instead of 6.02 times 10 to the 23rd and instead of the molar mass. So let's set it up. 4.93 moles of hydrogen gas takes up 110.43 liters at STP. This is a given. This is our answer. Label the chart to show how you set up converting moles of hydrogen into liters. Moles into liters. So where do we start?
4.93 moles.
Good. And then? Good. 1 mole on bottom, and then? Good. And when we do 4.93 times 22.4, it equals 110.43 liters. That's it. Got that down? Yep. We're going to do one more, but the other way. Well, two more. This one, and then one last problem. We're done. 78.22 liters of oxygen gas is equivalent to 3.49 moles of oxygen at STP. STP just means you're in a chemistry class. Label the chart below to show how you would set up converting the liters into moles. Liters into moles. Where do we go? 78.22 top left. Good. Then 1 liter on the bottom. I'm sorry?
42.4.
Thank you.
At the bottom.
Let go. Let go. 22.4 at the bottom. Good. On top?
1 mole.
1 mole. And then we get 3.49. Stop. So 78.22 times 1 divided by 22.4 equals 3.49. Oh, did you need to write that? Or are you good? Okay. Last one. Now a real one. 5.32 moles is equal to how many liters? Tell me what to do. 5.32. This is number 3 on the convert moles to volume practice puzzle piece. 1 mole at the bottom so that the units will cancel. On top, 22.4 liters, my special number. When I multiply that out, I get 119 something. And that's it. So much easier. Liters and particles are easy because your special number never changes. You either multiply or divide. Molar mass is pretty easy too. You just have to calculate the mass first, and then you can either multiply or divide for all of your one-step problems. And that is all 4 possibilities of questions on the 8A puzzle piece. We did molar mass calculations, we did mass to mole back and forth, we did particles back and forth, and we did volume back and forth. 8A is just this. When we do 8B, it's going to be multi-step. With the rest of the time, do the puzzle piece.
Say pa Isa. Say pa Yuli. Labias. I hate this.